This is a rather short section on marginal analysis. You would think that would be a long one on something that sounds so new, but actually it's a short one. The key is, when you think marginal, think one more. If you think of cost, what would be the cost of one more beyond where you are right now? If you're talking about revenue, how much more money are you going to get for one more of those items? Or marginal profit. What more profit are you going to get by producing and selling one more item? That's the key to the whole thing. Plus a little bit of calculus too. Okay, so notice that most of these are the ones I just mentioned. I'm going to drag something over off the side here. You don't notice that, but marginal cost, revenue, profit, and we've also got one for average cost. Quick hint. If this represents total cost, which it normally would, and C bar represents average cost, or average total cost. And here's one to write down. Now don't get a tattoo of this thing, really. C divided by X. In other words, the total cost divided by how many items that you got. That's your total average cost. But you could have figured that out yourself, but the C bar could have thrown you off. It's sort of like in statistics, if you've taken that. X bar represents the average. Moving on, keep that in mind. And we're talking about marginal cost. So it's the rate of change. In other words, how fast is the cost increasing at a certain point? We're talking about the rate of change of total cost per unit. That's why I said for each one, when you've got a quantity X. Let's take a look at that. Here we're talking about producing 10 items. Make up some kind of a feature or item you're going to produce. You're making 10 of them. And you're interested in what's going to happen if I bump that up to 11. Here's the cost for making 10 of them. And here's the cost for making 11 of them. There's 11 right there. So here's my curve. And because it's a curve and not a straight line, this can be a little bit tricky. But we can do it with a tiny bit of calculus. One way of getting this exactly is by taking the cost it would take to make 11 of those items and subtracting the cost it would take to produce 10 of them, and that gives you the cost for producing the 11th item, 11th TV set, 11th ballpoint pen, whatever it is. However, this could be a little bit tricky doing this. A lot more calculations. We have a shortcut thanks to calculus. Here's an example. We've got our total cost function, and this is the exact cost of producing the 101st pen, because this is the cost per 100 of them, this is the cost per 101, so this is for the 101st pen. Makes sense, right? Now, another way of doing it is to take the derivative of the cost function, and I'm going to use some Leibniz notation. He's the other person, along with Newton, who created the calculus. dc dx, which means the derivative of the cost with respect to X, the number of ballpoint pens in this case. Well, this is pretty easy. 500, the derivative of this is 0, the derivative of this is 3, and there's my derivative. And since there isn't even an X there, then the cost of making the next pen is $3. If there were an X there, then you put 100 into the X, and you get that answer. There you go. There's the cost for 101 ballpoint pens, the cost for 100, just subtract them, that's the cost for making the 101st ballpoint pen. So increasing the production level by 1. In other words, that's the rate at which the total cost is changing when you start at the production level of 100 and bump it up. The other way, using marginal cost, take the derivative, get an even 3. That means when you increase the production by 1, your total cost goes up by $3. Marginal revenue, basically the same thing. The only thing that's different is you're starting with a revenue function. You do all the same things. What is the total revenue? How is the total revenue changing per unit when you're at this level of selling? So here's an example. First, find the revenue function. Now this is the price, so don't get too quick on this. Revenue function, remember that's how much is coming into your coffers, and that's going to depend on the price. So there's the price, but that's not how much is going to come in if you have 1,000 items you're selling. You also have to multiply it by how many items there are. That's your revenue function. You'll see that very often, so take quick note of that. So we have to make an adjustment to this. If I want the revenue function, I'm going to have to multiply this by X to make the revenue function. Got that? Okay, let's get that out of the way. So X times the 117 is 117X. X times the next one. I'm going to make a slight adjustment to this to make the differentiation easier. X squared. Now, there's the revenue function. What's the revenue when X equals 16 tables? Well, if we want marginal, we're going to take the derivative of the revenue function. The derivative of the first term is straight 117. The derivative of the second term, you've already got a negative 1/4 there. Multiply that by 2, you'll have negative 1/2, and the x squared becomes x to the first power. I'll leave off the 1. There's your marginal revenue function. What's the marginal revenue at a level of 16 tables? Just put that 16 in where the x is, just like that. So you have 117 minus, there's an 8, so our marginal revenue will be $109. That means if you're producing 16 tables, you've got a certain amount of money coming in. If you sell 17 tables, how much extra money are you bringing in? $109. It's the marginal revenue. That's how much the revenue is changing at this level of selling. You got that? There you go. You're making table legs. There's your revenue function. Remember, that's one that I suggested you write down somewhere in your head. Multiply that by the price function or the demand function by x. Get the revenue function. There it is in a different form. I like the 1/4 myself. Differentiate that. There's another look for it. Put the 16 in. Evaluate. And there's your marginal revenue at a level of 16 of those, whatever it was, I forget. 16 items per table, that's it. So when the 16th table is sold, your tables are increasing the revenue at $109 per table. So the next one should bring in another $109. And if you just need a couple more, you could extend that to $109 for the next several tables until it changes. It should be pretty close. Not perfect, but if you just need a pretty good figure, the derivative can do a fantastic job for marginal revenue. Marginal profit, same deal. Start with the profit function, take the derivative, you'll get the marginal profit. And that'll be how fast the profit is changing when X items are produced. In other words, how much more are you making that's going in your wallet at a certain level of production and selling. So here's a pair of cost revenue functions. It's a little bit messy, but I think you can see that. I'll have to change or fix slide number 12 perhaps on that one. So first of all, you want all break-even points. If you want all break-even points, remember there are two ways of thinking of break-even points. Revenue equals the cost is one way, or profit equals 0, which you could also write as revenue minus cost equals 0, zero profit. Either way you think of it. So what is that? Well, that means you have to take 117x minus, and I'm going to make this 1/4 x squared, and you're going to subtract the cost, which is 225 plus 2x squared, and we want the break-even point, so that's where it equals 0. So what do we have? We have 117x minus 1/4 x squared minus 225 plus 2x squared equals 0. All right, let's put this in order. Let's move this down here. We'll put the 2x squared first, but we also have an x squared here. So we'll have, let's see, 8/7 x squared, taking the 2 and subtracting 1/4, plus 117x minus 225 equals 0. Well, one thing you could do if you wanted to, you could multiply all of this by 4, or just put it straight into quadratic formula. Where A is 1.75, B is 117, and C is negative 225. And you can get the break-even points right there. So let's take a look, and then we're going to get the marginal profit. Now we've sort of got the profit function right here, because we took revenue minus cost. So this is also the profit function. And the marginal profit, since we've got this up, marginal profit would be, we've got 7/4 x squared, so you'd have 7/2 x plus 1/17 would be the marginal profit. What's the marginal profit when you've got a 10? Marginal profit at 10, just put the 10 in there. 10 in there, minus 1/17. Do this a little bit cleaner for the next one. The marginal profit when it's 20, 7/2, 20 this time, minus 1/17, and so on. So here we go. This is what the graph looks like. Break-even points where the cost and the revenue are equal, that's where they cross. That's why we set the two equal to each other. And we had this. Now what they did was something I suggested, remember? Multiply everything by 4. It makes things a little bit easier perhaps, which makes the break-even formula look like this with no fractions. You can factor out the 9. I didn't see that, but you could. Or you could put that in the quadratic formula directly. Or if you see the factoring, you get it much faster. It's all up to you. But it is faster. Definitely, this is not hard to factor because the 50 and the 2 do give you 100. So you get two answers. X equals 2, X equals 15. Those are the break-even points. Second, there's the profit function. And we had that before. So there's the marginal profit function, cleaned up a little bit. Then all you have to do is put in the various points. At a level of 10 items, $72 is how much extra you'll be making, profiting, by producing one more item and selling it. At a level of 20 items being sold, one more will give you $27. Now, if you think about the actual numbers here, what's happening? In these early items, each extra one you make gets you $72 more. When you're up with this level of production with the 20, you're only making $27 extra by creating an extra item, going from 20 to 21, for example. If you make too many of them, you start losing money every time you make one more. Time to slow down. You might hit pause there and read it for yourself. I'm not going to read it for you. Marginal average cost. Now remember on this one, you'll start with the cost function. Don't forget this. This is easy to forget. Start with the cost function. Second, you have to get the average cost function. Remember that's the total cost function divided by how many items. And then you take the derivative of that average cost function. Got that? That's the change in average cost when one more item is produced. In a lot of cases, if you think about this, the more you produce, the lower the average cost will be. Not necessarily, but in general, that's typically the case. So here's an example, a little bit unfortunate the way I did it. That's another one I need to fix up. 13. All right, so notice that first of all, you find the average cost function, and then find the average cost of 1,000 radios, and then the marginal cost if 1,000 radios are produced. So here you go. First of all, find the average cost function. There you go. You can simplify it. Simplifying is a big deal. What's the average cost for making 1,000? Just put 1,000 in there. Evaluate it. $122 per item if you're making 1,000 of those items. Third, there's your average cost function. Notice in particular that on the previous slides, that third term looked like this. If you make it like this, rewrite it so that it's easy to differentiate using that part. So there we go, differentiate it, clean that up a little bit, and there's our function. Remember that x to the minus 2 means you bring the x squared in the denominator. So how is the average cost function changing on 1,000 items? Just put that 1,000 in your marginal average cost function, and it's 1.8 cents. Don't see cents too often anymore. And that, my friends, is almost it. Marginal propensity to save. What's marginal propensity to consume? Good one to check out. I'm going to leave this one for you. Okay, that's all for now. Time to go. Until later, keep smiling. Bye-bye.